here there will be no change in the estimation mechanism. So we will estimate the parameters of the model using the ordinary least square technique. The technique will be nothing but ordinary least square technique. Now all of you are familiar with the technique. What we do, we have to define the residual sum of squares, and we will minimize that residual sum of squares with respect to parameters of the model. So first we need to understand how we will define the residual sum of squares in context of a multiple regression model. In context of a multiple regression model, how we will define the residual sum of squares. The standard definition of residual sum of square is RSS is equal to summation EI square. I is equal to 1 to n. So this is our RSS. Now, in context of matrix algebra, the E vector will look like the U vector. Because it will just similar to UI. It is proxy to UI. The only difference between UI, that is the random error, and the residual, that is E, is U is not observable. We cannot realize it, whereas E is observable. U is based on unknown parameter beta, therefore not observable, whereas residual E is based on beta hat. Beta hat are all estimated values, and for that matter, the residual is observable. So we did all these things in case of two variable analysis. So we need to clarify those concepts from the earlier courses. So E1, E2 to En, this is the structure of EI or E. Now, if I multiply this vector, if I multiply by, say, transpose of it, this is of order and this is of order. So if I multiply these two things, what we will obtain? A matrix, a scalar, or a vector?
A matrix.
Matrix. And what will be the order of that matrix?
N cross N.
N cross N. Do we want that? When we are defining RSS, do we need a matrix? RSS is summation EI square. Is it a matrix? Summation EI square, my question is, what do you think? Summation EI square is a matrix or a vector or a scalar?
Scalar.
Anyone else?
Scalar.
Scalar? So it is a scalar. So we need something which will be of order 1 by 1. Which will be of order 1 by 1. So what we have to do? We have to consider, instead of this, we have to consider are we getting a scalar then?
Yes, ma'am.
And if I consider matrix multiplication, if I consider matrix multiplication, what will be the value of this product? What will be the value of this product? If I consider the matrix multiplication, anyone else apart from Aratric? What we will get?
Summation EI square.
Summation EI square. Very good. We are getting E1 square plus E2 square plus up to En square. So we are getting summation EI square. So in context of matrix algebra, to have summation EI square, should we consider E transpose E? Will E transpose E will give us summation EI square?
Yes, ma'am.
What do you think? It will give us summation EI square?
Yes, ma'am.
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
So we have to consider E transpose E here. In the last day, when we tried to define the variance covariance matrix from UI, you will find that we considered U transpose because we want to generate the variance covariance matrix. Here, the definition of RSS is summation EI square, sum of squared of residual terms. Okay, so we have to, given the fact that E is of order n by 1, we have to consider E transpose E. Now, once you understand that you need to consider E transpose E, you know the structure of the residual. E is defined as y minus x beta hat, whereas U is y minus x beta, E is y minus x beta hat. So in place of E, I am writing y minus x beta hat. So it is y minus x beta hat transpose into y minus x beta hat. X is a matrix, capital Y is a vector, beta hat is a vector, and from the last class you know the order of everything. So please tell me what is the order of Y? First, please
N
tell
cross
me
1.
order.
N cross 1.
N cross 1. What is the order of X?
N plus K.
আরেকবার বলো।
Ma'am, N by K.
N by K. Very good. What is the order of beta hat?
K cross 1.
K cross 1. Okay. So if you look at the term, look at this term, it is n by 1. Ultimately, it is also n by 1 because when we will consider the subtraction, we need the same order. So x beta hat, that will be of order n by 1. So from one n by 1 vector, we were subtracting the components x beta hat. Similar thing is happening here. Now, what is the order of y minus x beta hat transpose?
1 cross n.
1 cross n. And what is the order of this one? This is 1 cross n.
N plus 1.
N cross 1. So ultimately, when you will take the product, what will be the order?
1 cross 1.
1 cross 1.
1 cross 1.
1 cross 1.
Right hand side, everything is matching. There is no confusion, no inconsistency. Okay, so you will put the order. Always, whenever you will get the vectors, matrices, put the order. Check, compare the left hand side and the right hand side. Compare the two elements from, which you are, or two elements which you are using for subtraction, addition, check whether the orders are same or not. Because for the subtraction, addition, you need same order. Otherwise, you will be not able to subtract or add. So the standard rules of matrix algebra that will be applied in context of k-variable analysis. Now I am taking the transpose and breaking the things, considering the entire expansion. Now when I am taking transpose of the first factor, I am getting y transpose minus beta hat transpose x transpose. Am I right? If I take transpose of these element, am I getting this y transpose minus beta hat transpose x transpose?
Yes, ma'am.
Okay. So what I am doing, first I am considering y transpose and multiplying that y transpose with y and x beta hat. So y transpose y minus y transpose x beta hat. Then I am taking beta hat transpose x transpose, multiplying this with this y and x beta hat. So it is beta hat transpose x transpose, which is coming from this part, into y. Then beta hat transpose x transpose x beta hat. So in this way, we are getting all four elements from this E prime E. Now I am keeping y prime y as it is. And this I am writing as minus 2 y transpose x beta hat. Minus 2 y transpose x beta hat. Okay. However, this term was y transpose x beta hat and this was beta hat transpose x transpose y. So if you look at the two elements, actually this one is the transpose of first. This is nothing but transpose of this element. Am I right? If you take transpose of this element, are we getting this one?
Yes, ma'am.
Yes.
We are getting this one. Now, individually, y prime x beta hat as well as beta hat prime x prime y are scalar. These are scalar. Okay, so if I look at the order, y is of order n by 1. So y transpose is of order 1 by n. X is of order n by k. Beta hat is of order k by 1. So it is a scalar of order 1 by 1. Similarly, if you consider the order of this, beta hat transpose, what will be the order of beta hat transpose?
1 by k.
1 by k, k by n, n by 1. So the order is 1 by 1. So when it is a scalar, that is a fixed number, say 10. Transpose of 10 is 10 or not? If you take transpose of a
Yes,
scalar,
ma'am.
what will happen?
Yes,
That
ma'am.
scalar will remain as it is. Okay. Following that principle, that is, since y prime x beta hat as well as beta hat prime x prime y, these are scalars, and the second is the transpose of the first, we are combining these two elements and writing minus 2 y transpose x beta hat. The third element I'm keeping as it is, beta hat transpose x beta hat. So this is the format, okay. And with the help of this format, we will derive the estimated value of beta hat. The first term, y prime y, is basically TSS, total sum of squares, summation yi square. The first term is nothing but summation yi square. So it is TSS. Okay. And it does not consist any beta hat term. So when we will minimize E prime E and derive the value of beta hat, the first element will do not have, the first element will not have any impact on estimation. When we will consider derivative of E prime E with respect to beta hat, the first element will vanish. So we have to understand the role of the second and the third element. We are not that much familiar with differentiation of matrices and vectors. Therefore, I'll discuss everything step by step. When we will take the derivative of E prime E, actually we have to take differentiation of second and third term following the rule of differentiation which we follow in case of matrix algebra. Okay, so that part we need to understand a bit. Now, before going to differentiation, please look at the points which has been summarized here. Y prime x beta hat is a linear function of beta hat. Y prime x beta hat is a linear function of beta hat. So when we will take derivative with respect to beta hat, we are understanding that beta hat term will be not there. Okay, if it is a standard case, and if you take derivative of E prime E with respect to beta hat, we have some hunch that we will get minus 2y prime x. However, when we will learn or we will revise the differentiation with respect to vector as well as matrices, you will find that there will be a little bit change. Okay. At least this part we are understanding. When we will take derivative with respect to beta hat will not appear because there is single beta hat, or this coefficient is a linear function of beta hat. The second coefficient, or the third one, beta hat prime x beta hat, is a quadratic function of beta hat. Okay. Now here x prime x is in between. However, we are multiplication of beta hat prime by beta hat. Beta hat prime is a vector of 1 by k, and beta hat is a vector of k by 1. So actually it is beta hat 1 square plus beta hat 2 square up to beta hat k square. So this term we will get. So it is the squared term. Okay, it is sum of squared terms. So when we will take differentiation for the third term in terms of beta hat, I hope you are understanding. Beta hat term will come back. So once we understand what we will get from the second and third term when we will take derivative, following the first order conditions or following the rule of first order condition, we will set the value to be equal to 0 and we will get the value of beta hat OLS. Okay, so let's try to understand the differentiation of the first and the second, or second and the third term one by one. So first, I'm talking about differentiation of linear form. Now, linear form means summation Ci xi. In terms of matrix algebra, C transpose X. To have Ci xi, we need C transpose X, where C is of order n by 1 and X is of order n by 1. C is of order n by 1, so C transpose is of order 1 by n. Okay, so a row vector will be multiplied with a column vector. A row vector, summation Ci xi means a row vector will be multiplied with a column vector. This is of order 1 by n and this is of order n by 1. This is the idea. So we have C prime x, this kind of structure. Now when we are taking derivative with respect to x, we are getting the term del C prime x by del x. This means C is a column vector. So column wise, we are taking differentiation of this entire sum, that is sum of Ci xi. First in terms of x1, then in terms of x2, and finally in terms of xn. So what we are doing, I have summation Ci xi. I am taking derivative first with respect to x1, then with respect to x2, then with respect to x3, and so on, and then finally with respect to xn. Now, when I am taking the derivative, I have to consider the column-wise derivative because originally C is a column vector. So, when I am taking the derivative, from the first term, actually I have all n terms here. However, when I am taking the derivative with respect to x1, I am getting back c1 because it is c1 x1 plus c2 x2 plus cn xn. So when I am taking the derivative, I have to change the, slide. Otherwise, the mouse will give me this kind of problem. So when I'm taking the derivative with respect to C prime, it will give me C1 back. When I'll take the derivative with respect to x2, I'll get C2 back. Finally, when I'll take the derivative with respect to xn, I'll get Cn back. So what I am getting is nothing but C, nothing but C. I started with C prime x. When I am taking the derivative with respect to x, we understood we will get the C related term. X will be not there because it is linear in x. However, we are not getting C transpose, rather we are getting C. In our analysis, we have in the second term, we have y prime x beta hat minus 2 y prime x beta hat. Okay. So if I take derivative of y prime x beta hat with respect to beta hat, y prime x beta hat with respect to beta hat, in that case, we will not get y prime x, rather we will get transpose of this, that is x prime y. We will get x prime y. So this is about this term. So when we will take the derivative, we will get minus 2 x prime y, minus 2 x prime y. Okay. Next, let's consider the quadratic. Yes, Darpa?
আরেকবার বলবেন ওই কেন ওটা ডেরিভেটিভ করলে প্রাইম হচ্ছে, মানে ওটা ট্রান্সপোজটা হয়ে যাচ্ছে ডেরিভেটিভ করলে।
Please follow this mechanism. I started with C prime x, okay, where C is of order n by 1. When we are taking derivative, I have to consider the column-wise derivative following the basic structure of C. So when we are taking derivative of C prime x with respect to x1, actually I am taking derivative of C1 x1 plus C2 x2 plus Cn xn. The element we will get when I am taking the derivative is C1. Next, if I take the derivative with respect to x2, we will get C2. So the second term will be C2. If I take derivative with respect to xn, we will get Cn. So once I check this column, it is simply C, not C transpose. Actually, I'm taking derivative of the sum. I'm writing the transpose to get the sum. Whereas when I'm taking the derivative with respect to x1, x2, xn, I'm getting the coefficients, not their transpose. Okay? So I said, following the similar mechanism, if I take derivative of y prime x beta hat with respect to beta hat, I'll not get y prime x. Rather, I'll get the transpose of that is x prime y. Here, starting from c prime x or c1 x1 plus c2 x2 cn xn, when I am taking the column-wise derivative, I am getting the original column of order n by 1, that is c. So here, if I take the derivative column-wise with respect to beta hat, I'll not get y prime x, rather I'll get transpose of this, that is x prime y. Getting the point?
Yes, ma'am.
Next, differentiation of quadratic form. Consider the form x prime ax. Our format was beta hat prime x prime x beta hat. So pre-multiplied with beta hat prime and post-multiplied with beta hat. And in between there was a symmetric matrix. Okay? X prime is of order k by n. X is of order n by k. So x prime x is of order k by k. So it is a symmetric matrix. So we have a symmetric matrix in between. It is pre-multiplied with a row vector beta hat prime and post-multiplied with a column vector beta hat. So similar kind of structure I am considering here. X prime ax, where A is a symmetric matrix of order n by n. It is a square symmetric matrix of order, say, n by n. It is pre-multiplied with x prime and post-multiplied with x, where x is a vector of n by 1. X is a vector of n by 1. So x is a vector and capital A is a matrix. Okay. In our example, beta hat is a vector and x prime x is a symmetric matrix of order k by k. And x is a vector of order k by 1. So similar kind of context I am considering. Now A is a symmetric matrix that indicates A is equal to A transpose. Now I am considering a very simple case to understand the logic of differentiation or the steps of differentiation. I am considering A is of order 2, a 2 by 2 symmetric matrix having the elements A11, A12, A21 or A12, symmetric. So A21 can be replaced by A12, A22. So it is a symmetric matrix A11, A12, A12, A22. And I am pre-multiplying this with a row vector of order 1 by 2 and post-multiplied by a column vector of order 2 by n. So in our example, n is basically 2. N is basically 2. Now if I consider this, it will be based, if you have pen and paper, to check whether we are getting this equation. I'm first multiplying this matrix with this row vector, then we are multiplying the entire thing with a column vector and getting this. So please check and please confirm that you are understanding this equation. All of you are aware of multiplication principle, so please do a rough work and please check whether we are getting this equation or there is any mistake. Once you get the result or understand the matter, please confirm. Or if there is any problem, please let me know.
Yes, ma'am, we get a form of this service.
We are getting this equation. Others?
Yes, ma'am, got this.
Got this? Okay. So hope rest of the students will also get this because 2 people confirmed that we are getting this result. Next, we will take derivative. Once we understand this equation, we will take the derivative part. We will take the derivative of x prime ax with respect to x. Now, when I am taking the derivative with respect to x is a column vector. So, first I'll take the derivative with respect to x1, then with respect to x2. If it is a column vector of order n by 1, I have to take derivative then with respect to x3, x4, and we'll move up to xn. So following the column vector x, I'm taking the derivative of x prime ax. So I'm first taking derivative with respect to x1. If I take derivative with respect to x1, from this equation we are getting 2a11 x1 plus 2a12 x2. If I take the derivative with respect to x2, I'm getting 2a12 x1 plus 2a22 x2. If any confusion, if anyone does not understand this, please tell me. So once I get these 2 components, these I can write as 2ax. So again, please check and tell me whether this can be summarized as 2ax. টু তো বাইরে বার করে নিচ্ছ, so 2 will be there. a11 x1, a12 x2, a11 x1 plus a12 x2, উপরেরটা নিচেরটা a12 x1 plus a22 x2. So can we summarize this as ax?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Very good. So we started with x prime ax. We started with this x prime ax. If I take derivative of x prime ax, we get 2ax. Actually, I'm considering square x prime and x, that is giving square terms. So when we consider the derivative of x square, we will get 2x. So from that part, we are getting 2x and a is coming back. So 2ax, this format is coming. Now in our case, we had beta hat prime, x prime x, beta hat. So what we will get out of this, if I take derivative of this with respect to beta hat, if I take derivative of this term with respect to beta hat, what I'll get?
Beta hat x
2.
bar x. 2 into beta hat x bar x. Sorry.
2 into beta hat. This I'll get back. Everyone?
Will it be 2 into x bar x times beta hat?
Anything is possible. No problem. Okay. So we are getting this. What is the order of x prime x beta hat or beta hat into x prime x?
Ma'am, we cannot like multiply beta hat with beta hat. We cannot do beta hat x prime x because the number of rows and columns for the product are not like compatible.
Matching. Not matching. Right?
Yeah.
X prime x is k by k and beta hat is k by 1.
Yes, ma'am.
Okay, so it will be best, so we should write this thing in this format, 2x prime x beta hat. In that case there will be consistency in the presentation. However, here we will do the first order condition. Actually we will write beta hat in terms of the variables in the model, so finally it will not matter. However, in terms of matrix algebra, if I want to keep the consistency, we will write the thing as 2x prime x beta hat.
Ma'am,
Here also, look at this thing. We are writing the presentation as 2ax. Okay, 2 into the symmetric matrix into the vector. Okay, so in that format, we will present the term which we have in our analysis. Okay, because we are getting the things in this way. So if I take the derivative of beta hat prime x beta hat with respect to beta hat, we will get 2 the symmetric matrix x prime x multiplied with the vector beta hat multiplied with the vector beta hat. So in total, if I consider the derivative del e prime e by del beta hat, we are getting minus 2x prime y from the linear term, and from the quadratic term we are getting 2x prime x beta hat. By first order condition of minimization, we are setting this to be equal to 0. So we are getting the equation x prime x beta hat is equal to x prime y. This is the set of normal equations. This is the set of normal equations. This is the set of k number of normal equations. K number of normal equations. Now, in case of two variable analysis, we have two parameters, alpha and beta. So we get two normal equations to solve this. In case of multiple regression model, we have k number of beta to solve. We have to derive the values for k number of beta. So we will have k number of normal equations. Solving k number of normal equations, we will get the value of beta hat vector. Actually, we will derive the value of beta hat vector. We have k number of beta in our analysis. So all these beta values or estimated beta vector we will obtain solving these k number of equations. So remember, this x prime x beta hat is equal to x prime y. This is a set of solving this simultaneously, we will get the value. Just a minute. আচ্ছা বাড়িতে খুব সমস্যা, এমনি আমি চালাচ্ছি, ক্লাস নিচ্ছি, হ্যাঁ বলছি, হ্যাঁ হ্যাঁ বলে দিন ও ছাত্রদের বলেছি, হ্যাঁ আমি আসছি আর বলছি, হ্যাঁ 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 পড়া আছে, হ্যাঁ 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 জয়া কৃষ্ণ কুমার বলে গেছে আর দেববঙ্গে সূত্র আর শরীর 18 আর 19 তারিখ। জয়া কৃষ্ণ কুমারটা মানে এই সপ্তাহের মধ্যে দেববঙ্গেরটা সূত্র আর শরীর 18 আর 19 তারিখ। দুভাগে ভাগ করে করতে হচ্ছে। লেকচারের রেকর্ডিং এই সমস্ত দিতে পারি। আপনি দেখুন একটা হচ্ছে যে রেজিস্ট্রেশনটা করেছিলাম, তো অনেক ক্যান্ডিডেট করেছে, সেইগুলো আপনার এসবিআই পোর্টালে সব জমা করেছে। আচ্ছা 7-8-9 তারিখে ইনি করেছেন এত ঘন্টা ধরে। হ্যাঁ 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 আচ্ছা আচ্ছা ঠিক আছে। হ্যাঁ জুম যে লিঙ্কে হয়েছে, জুমে হয়েছে, কারণ এরা সব আমেরিকা জুমে করছে, ওরা নিজেরাই সেট করছে। বেশ 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 হ্যাঁ 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 কিন্তু উনি দিয়েছেন 22 ঘন্টা, সেটা ঘন্টা নিয়ে আমরা তো আর আমার কান নেই, যা ঘন্টা হয়েছে হয়েছে, 22 ঘন্টা হয়েছে। হ্যাঁ হ্যাঁ আমরা সেটা না স্যার ভাগ করতে পারবো না, বিকজ দেখুন পড়াবার সময় প্র্যাকটিক্যাল করাতে শেয়ার করেছে আর জাকিরও অনেকটা করেছে, এই জন্য মানে এগুলো তো ঠিক অনলাইন হচ্ছে, ফলে আমাদের দিক থেকে আমরা কিছুটা সফটওয়্যার বোঝাচ্ছি। হ্যাঁ এইসব পারে। বুঝতে তো পারছি না স্যার, সবই তো ট্রায়াল। হ্যাঁ 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 আচ্ছা আচ্ছা আমরা বলেছি না আসলে ওনাকে আপনি দিয়ে দেবেন। সুব্রমণিয়ান ভদ্রলোক, তিনি হার্ভার্ড ইউনিভার্সিটিতে, হ্যাঁ দেবেন, হ্যাঁ দেবকমের নামও ওখানে ছিল, টেন্টেটিভ কেমব্রিজ। হ্যাঁ হ্যাঁ এইটাই আমরা ভাবলাম, এটা আমি এবং যাকে এটাই ভাবলাম যে এটা তো আপনি ক্লিয়ার করে দিতে বলেছিলেন অ্যাকাউন্টটা, তো আমরা এই 111 টাকা নিয়ে কি করবো, সেই কারণে আমি ওটা লিখে দিয়েছি। হ্যাঁ 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 হুম মানে কি করবো সেই জন্য আমরা বুঝতে পারছি না এটা তো অ্যাকাউন্ট কি হ্যাঁ 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 এইটা আমাদের কিছু করার নেই আমরা ক্লিয়ার করার জন্য এটা লিখে দিয়েছিলাম আচ্ছা লিঙ্কটা হ্যাঁ তাহলে সার্টিফিকেশন বলতে পারে না তো আপনাকে ওই লেকচারের রেকর্ডগুলো সব এগুলো অনেক বড় বড় হ্যাঁ মানে প্রুফ হচ্ছে ওইটা হচ্ছে পারফেক্ট প্রুফ হ্যাঁ রেকর্ডটাই তার মানে কিন্তু অ্যাকচুয়ালি আপনি চাইছেন মানে যেটা দিয়ে শুনবে সেটা তো রেকর্ডটা রেকর্ডিংটাই চাইছেন আচ্ছা আচ্ছা হ্যাঁ হ্যাঁ বুঝতে পেরেছি বুঝতে পেরেছি হুম হ্যাঁ হ্যাঁ হুম হ্যাঁ মানে এটা যদি আমরা ইউটিউবে করতাম এটা আপনার মানে একটু সুবিধা হতো মানে হ্যাঁ হ্যাঁ ছবি নেই আর ওই তো আপনি বললাম যে রেজিস্ট্রেশনটা আপনাদের ওখানেই হয়েছে প্রচুর ক্যান্ডিডেট রেজিস্ট্রেশন করেছে তোর কাছে সেগুলো একটা প্রুফ করতে পারে যে জিনিসটা হয়েছে ঠিক আছে আর একটা বলছি লিঙ্কটা দুটো আমাকে দিচ্ছি দয়া করে তোমাকে আলাদা কি হচ্ছে তখন সেটা আচ্ছা ওদের ব্যাংকে বা ট্রান্সফার হবে এটা আপনার কোনো আচ্ছা যে ওরা ব্যাংক ডিটেলস পেয়ে গেছে কি নিয়েছে তো সেটা পেলে পরে কি দিয়ে কথা বলতে হবে ব্যাংক ট্রান্সফার হয়ে যাওয়ার পর কি লিখতে হবে ওরা পেয়েছে আচ্ছা 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 হ্যাঁ সেটা তো আমরাও চাইছি যে ব্যাংকে ট্রান্সফার হয়ে যাবে আচ্ছা ঠিক আছে ঠিক আছে ঠিক আছে ঠিক আছে ঠিক আছে আচ্ছা আর একটা জিনিস আমি একটু অনেক নাম্বারকে একটু মেল করছিলাম আমাদের আগের সেমিস্টারে যারা গেস্ট প্রফেসর পাঠিয়েছিলেন তো প্রায় 7-8 দিন আগে প্রফেসর অনেক বসে ওরা একটা মেল করলেন যে আমরা এখনো টাকাটা পাইনি এবার এটা তো অনেকগুলো রিসার্চ ভুল করে দিয়েছি তার 25,000 আছে কারো 12,000 যা যেমন বলছিল সেই গেস্ট প্রফেসরদের টাকার ঠিক আছে এটা একবার আমার জানাচ্ছি ওরা আমাকে মেল করেছে হ্যাঁ 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 সুরজ দিয়ে করেও এসেছিল হ্যাঁ 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 ঠিক আছে স্যার যদি কোনো ভুল হয় আরেকটু লিখবেন আমি ভুল হবে না আমি শুনে নিচ্ছি আমি ঠিক মতো হ্যাঁ কারণ তাহলে হচ্ছে আমাদের হ্যাঁ আচ্ছা আচ্ছা ও আচ্ছা হ্যাঁ কারণ আগে আমাদের যখন রেজিস্ট্রেশন হতো যখন ধরুন আমরা খোলা ছিল ইনস্টিটিউট তখন তো আমাদের ওই আমরা জেনে নিতে পারতাম উল্টে ওকে জেনে নিতে পারতাম হ্যাঁ হ্যাঁ, ঠিক আছে। বলবেন তখন যান। আচ্ছা। Sorry. So I hope by this time you understood, this is the series of normal equations, and solving this k number of normal equations, we will find the value of beta hat OLS, and this is the value. Beta hat OLS is equal to x prime x inverse x prime y. X prime x inverse x prime y. Okay. Actually, x prime x we are bringing here. In other words, we are pre-multiplying the left-hand side with x prime x inverse, and naturally we have to pre-multiply x prime y, that is the element we have in the right-hand side, with the same element, that is x prime x inverse. So, if I do so, I am getting beta hat OLS is equal to x prime x inverse x prime y. Now, in general, in a two-variable model, what is the value of beta hat? What is the value of beta hat in a two-variable model? Anyone?
Summation over xi minus x bar times yi minus y bar by summation xi minus x bar squared.
Yes. Or, if I just neglect the bar part, it is summation xi yi divided by summation xi square. So, are we getting the similar format here? Are we
Yes, ma'am.
getting
Yes, ma'am.
format? We are getting the similar format, equivalent format. In case of matrix algebra, there is nothing like by. We cannot write x prime y by x prime x. I have to write x prime x inverse x prime y. Okay? So same thing we are getting. However, we are getting here the bunch of values. We are getting all k number of beta values, solving k number of normal equations, and all these values are given by x prime x inverse x prime y. Okay?
ম্যাম
Yes?
ম্যাম এক্স প্রাইম এক্সটা সিমেট্রিক কেন হচ্ছে বলবেন?
অর্ডারটা ইয়ে করো, এক্স এর অর্ডার কত
n ইন্টু কে,
আর এক্স প্রাইমের অর্ডার কত?
কে ইন্টু n।
এক্স প্রাইম এক্সটা করো তাহলে।
আর ম্যাম অর্ডারটা একই থাকছে, আমি আমি বলছিলাম যে ওটা মানে এলিমেন্ট গুলো একই হবে।
এলিমেন্ট গুলো একই হবে মানে কতটা বুঝতে পারছি না।
ম্যাম সিমেট্রিক ম্যাট্রিক হওয়ার জন্য ওই এ ম্যাট্রিক্স ইজিক্যাল টু হচ্ছে এ ট্রান্সপোজ, তার জন্য আমি বলছি অর্ডারটা একই আছে আর এলিমেন্ট গুলো কি একই থাকবে যদি আমরা রো ওয়াইজ কলাম ওয়াইজ চেক করি?
একটা এক্সাম্পল নিয়ে করে ফেললে তুমি দেখতে পাবে একই থাকবে কিনা। ঠিক আছে, এইরকম একটা তুমি A11 A12 A12 A22 এরকম একটা ম্যাট্রিক্স আছে, ধরো তোমার এক্স, আর এর ট্রান্সপোজটা নাও, দিয়ে মাল্টিপ্লাই করো দুটো ম্যাট্রিক্সে, তাহলেই দেখতে পাবে তারা A11 A12 A12 A22 থাকলো না বদলে গেল, তাই না?
আচ্ছা
এক তো থাকতেই পারে না, না? তুমি এই এলিমেন্ট গুলোকে আবার ওই এলিমেন্ট দিয়ে মাল্টিপ্লাই করছো, তোমার এটাই তো কোয়েশ্চেন নাকি?
হ্যাঁ 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 হ্যাঁ।
তো একটা ম্যাট্রিক্সকে তার ট্রান্সপোজ দিয়ে মাল্টিপ্লাই করো, এবার দিয়ে কি কি এলিমেন্টস রো ওয়াইজ কলাম ওয়াইজ এসেছে দেখো, তাহলেই বুঝতে পারবে। এরকম ক্ষেত্রে সব সময় একটা এক্সাম্পল করে দেখে নেবে যদি কোনো কনফিউশন। other question, regarding the normal equations and how we are getting beta hat OLS? Anyone, any question?
Ma'am,
Yes.
here K is lesser than N, right?
Always. Last day I talked about this assumption,
Right.
rank of the matrix, etc. Rank condition, the assumption was there. The typical assumption or the new assumption which we incorporated in context of K variable analysis, look at that. N will be always very, very greater than K, otherwise we will not have the sufficient degrees of freedom. X should have full column rank. We did this.
Yes, ma'am, got it.
Okay. So here you don't need to reread all these lines, because this is a lecture which I gave in some workshop, So for that matter, I added some more points because that was related to some advanced course. So, however, you don't need to follow these lines. Already this thing is done. We learned this thing in the assumption part. So this is all about the estimation of beta hat. Next, we consider the properties of beta hat ONS. Properties of beta hat ONS. In case of two variable analysis, we talked about three properties. It is linear in Y, it is unbiased estimator, and it is minimum variance estimator. Combining all these three, we called beta hat OLS the blue, best linear unbiased estimator. Okay, I hope you can remember all beta hat estimator we got in case of two variable analysis where blue, best linear unbiased estimator. Okay, so similar kind of properties we are discussing here. Here, I'll not show you the beta hat has the minimum variance that in your syllabus, the minimum variance, comparing the variances between two beta hat, etc. That will be the part of your syllabus. However, in case of K variable analysis, I'll stop with calculation of variance of beta hat. However, I'll not show that the variance of beta hat OLS is minimum compared to other one because the calculation needs some more concepts regarding the matrix algebra, etc. The idempotent matrix, etc., etc. Therefore, I'll not consider that part. Linear in Y. Since Y is a linear function of U, so will be beta hat. Okay. The marginal distribution of each beta hat J would be normal. Okay. So, beta hat will be linear in Y. Now, if you look at the value of beta hat, it is x prime x inverse x prime Y. Okay. So, just looking at the formula of beta hat OLS, we are understanding it is linear in Y. A single Y is there. It is not Y prime Y or Y prime, it's Y. So, beta hat is linear in Y. Next, to prove that beta hat is an unbiased estimator of beta, we have to show expectation of beta hat OLS is equal to beta. Now, beta hat OLS, remember here we are considering all K number of beta hats simultaneously. So, when I am writing beta hat OLS, so basically it's a vector. It's a vector of order K by 1. It's not a single element, single beta hat. It's a scalar. Now, beta hat OLS is equal to x prime x inverse x prime Y. Y I am replacing by x beta plus U. The set of equations, the way we presented the K variable model. Y we are replacing by x beta plus U. Now, as we do so, we are getting x prime x inverse into x prime x into beta. So x prime x inverse will be adjusted with x prime x and create one identity. So we will get beta plus x prime x inverse x prime u, x prime x inverse x prime u. So beta plus x prime x inverse x prime u, that we are getting. So expectation of beta hat is equal to expectation of beta, which will be beta plus x prime x inverse x prime expectation of u. Now expectation of u is equal to 0. Expectation of u vector is equal to a null vector, 0 vector. If we put that value, the second term will vanish and we will get expectation of beta hat vector is equal to beta vector. Expectation of beta hat vector is equal to beta vector. Hence, we can claim that beta hat OLS, or the series of beta hat OLS we are getting, that is unbiased estimator of series of unbiased estimators of beta. Okay. So in this way, we can prove all beta hat OLS we derived using the K normal equations are unbiased estimators of all corresponding betas. Next, variance of beta hat. In the last class, I discussed in context of K variable analysis, when I'll talk about variance, actually I'll derive the variance covariance matrix, where the diagonal elements will give the variances, whereas all off diagonal elements will give the covariances. Okay. So separately here, you don't need to find out variance of alpha hat, variance of beta hat, and so on. And you don't need to find out separately covariance between beta 1 hat and beta 2 hat, beta 2 hat and beta 3 hat, beta 1 hat and beta 3 hat. No, it's very easy. Using matrix algebra, simultaneously we will derive all possible variances and all possible covariances. Okay. So variance covariance matrix of beta hat, that we need to find out. We are writing var of beta hat, however, the entire matrix will be derived. Okay. In this case, we need a matrix, remember that. The expectation will be there, then beta hat minus expectation of beta hat. Beta hat minus expectation of beta hat is of order k by 1, because beta hat is of order k by 1. Therefore, beta hat minus expectation of beta hat, that is also of order k by 1. We are multiplying this with its transpose, beta hat minus expectation of beta hat transpose, which is of order 1 by k. So the entire thing is of order k by k. Okay. So it is understandable we are considering a squared symmetric matrix. And the squared symmetric matrix is nothing but the variance covariance matrix of beta hat. Now, what is beta hat minus expectation of beta hat? Beta hat OLS is equal to beta plus x prime x inverse x prime u. So beta hat minus beta is nothing but x prime x inverse x prime u. So in place of beta hat minus expectation of beta, we are writing x prime x inverse x prime u. Okay. Then beta hat minus expectation of beta hat transpose. So this entire thing will be written as u transpose x prime x inverse. Now when there is x prime x, which one is first x, which one is second x, we will be not able to distinguish. So it will look alike. If you take transpose of x prime x, it will be x prime x. So we are getting this. We will implement expectation on the relevant term. So it will be x prime x inverse, x prime, expectation of u prime, x prime x inverse. Expectation of u prime means the variance covariance matrix of u. Last day we found that in presence of homoscedasticity and non-autocorrelation, expectation of u transpose is sigma square I. So this term will be sigma u square into identity matrix. Okay? Sigma u square is a constant term. I is an identity matrix. If we multiply this with anything, we will get back that thing only because it is identity. So sigma u square I'm keeping outside. I am multiplying with x prime x. So I'm getting x prime x inverse, x prime x prime x inverse. So 1 x prime x will be adjusted with 1 x prime x inverse and we will get a single x prime x inverse. So finally, the variance covariance matrix of beta hat OLS is given by sigma u square x prime x inverse. In case of two variable analysis, variance of beta hat is given by sigma u square this kind of thing. So similar kind of thing we are getting here. Since we have the entire matrix, not a single value, we are getting the format sigma u square into x prime x inverse. Okay? However, structurally the things are very, very similar. Structurally, the things are very, very similar. Okay? So this is the variance covariance matrix of beta hat. Okay, the diagonals will give the variances, of diagonal will give the covariances. The proof of minimum variance I'll not do here. That you will do later in some advanced course. Okay, at PG level, generally students do these things. So beta hat is the minimum variance unbiased estimator, MVUB, that is in the class of all linear and unbiased estimators of beta hat. The OLS estimator has the minimum variance. So that I am putting in the note. The proof you did in case of two variable analysis. So you have the idea how we can compare two unbiased estimators and we can prove that one which is derived on the basis of OLS gives us the minimum variance. Okay, so this completes the analysis on beta hat. We have shown how we can find out the estimated values of beta hat once the regression model is there, and the properties of beta hat coalesce. Anyone, any question? Especially on the properties part, because estimation you did.
Ma'am, ma'am, variance of beta হাটের এটা একটু এক্সপ্লেইন করতে পারবেন?
কোন পার্টটা বলো, পুরোটা বলবে আরেকবার?
না ম্যাম, সেকেন্ড লাইনটা, মানে আপনি বললেন বিটা হ্যাট মাইনাস এক্সপেকটেশন অফ বিটা, তো ওখান থেকে পরের ইয়েটা কি করে আসছে?
আচ্ছা, এই লাইনটা বুঝতে পেরেছো? থেকে বলবো?
হ্যাঁ ম্যাম একটু প্লিজ বলুন না।
বিটা হ্যাট মাইনাস বিটা, এইটা দেখলে তো এক্স প্রাইম
ইয়েস
এক্স
ম্যাম,
প্রাইম ইউ হলো।
ইয়েস ম্যাম, ইয়েস ম্যাম।
আচ্ছা, তাহলে একটু লিখে ফেলি, বিটা হ্যাট মাইনাস বিটা, দ্যাট ইজ এক্স প্রাইম এক্স ইনভার্স এক্স প্রাইম ইউ। ঠিক আছে? আচ্ছা, এবার তোমার আছে বিটা হ্যাট মাইনাস বিটা ইন্টু বিটা হ্যাট মাইনাস বিটা ট্রান্সপোজ, মানে তোমাকে এবার বার করতে হবে ট্রান্সপোজ। তাহলে কি হবে, ইউ ট্রান্সপোজ এক্স, দেখো এইটা বুঝলে,
ইয়েস ম্যাম, ইয়েস।
এ বি হোল ট্রান্সপোজ ইজ ইকুয়াল টু বি ট্রান্সপোজ এ ট্রান্সপোজ। তাহলে
হ্যাঁ ম্যাম, হ্যাঁ।
জিনিসটা ট্রান্সপোজ নিয়েছি, ইউ প্রাইম এক্স এক্স প্রাইম এক্স ইনভার্স।
ইয়েস, ইয়েস।
এইবারে দুটোকে পাশাপাশি লিখেছি, এক্স প্রাইম এক্স ইনভার্স এক্স প্রাইম ইউ, ইউ প্রাইম এক্স এক্স প্রাইম এক্স ইনভার্স। ঠিক আছে?
হ্যাঁ ম্যাম।
এক্সপেকটেশন ছিল সেটাকে এরপরে এখানে ঢুকিয়ে নিয়েছি, বিকজ এগুলো তো নন স্ট্যাটিস্টিক, তো এই পার্টটার উপর এক্সপেকটেশন হলো। এবার এক্সপেকটেশন অফ ইউ ইউ প্রাইম by assumption of homoscedasticity and non-autocorrelation is sigma u square I.
ওকে, ওকে, ওকে। হ্যাঁ বুঝতে পেরেছি।
ঠিক আছে? এবার সিগমা ইউ স্কোয়ার কনস্ট্যান্ট বাইরে করে দিলাম, তাহলে এরকম হলো এক্স প্রাইম এক্স ইনভার্স এক্স প্রাইম এক্স এক্স প্রাইম এক্স ইনভার্স। এবার এই দুটো ধরো অ্যাডজাস্ট করে গেল, তাহলে পড়ে থাকলো এইটা, এখান থেকে তো একটা আইডেন্টিটি তৈরি হয়ে গেল, এইটা পুরোটা একটা আইডেন্টিটি দিয়ে দিল, এই আইটা এর সাথে মাল্টিপ্লাই করলে খালি এটা থাকে। ক্লিয়ার হয়েছে?
হ্যাঁ ম্যাম বুঝতে পেরেছি, থ্যাংক ইউ।
ম্যাম,
হ্যাঁ,
ম্যাম ফার্স্ট স্টেপে ওটা এক্সপেকটেশন অফ বিটা হ্যাট মাইনাস এক্সপেকটেশন অফ বিটা হ্যাট ইনটু ওই বিটা হ্যাট মাইনাস এক্সপেকটেশন অফ বিটা হ্যাট ট্রান্সপোজ তো।
হ্যাঁ ট্রান্সপোজ, ট্রান্সপোজটা একটু দেখতে খারাপ, এই যে এখানে আছে, বড় করে দিয়ে দেবো।
ঠিক আছে
ম্যাম।
হ্যাঁ বলো।
So now just a minor clarification. So we don't use the T notation here, right? We just use the dash notation for transpose.
হ্যাঁ, টিটা একটু ক্লামজি হয়ে যায়, তুমি করতে পারো, এর তো কোনো ডিফারেন্স নেই, তুমি তুমি যে নোটেশন ইউজ করবে তোমার যাতে কমফোর্টেবল ইউ ডু দ্যাট। সাধারণত আমরা ড্যাশ ইউজ করি,
Okay.
টি লিখে গেলে ঠিক আছে, কোনো অসুবিধা নেই। আর কারো কিছু? সো ফার্স্ট এখান থেকে শুরু করবে, চেক করো হাউ টু ডিফাইন আরএসএস, দেন হাউ টু ডিরাইভ বিটা হ্যাট, the value of beta hat, x prime x inverse x prime y, properties, unbiasedness, and calculation of variance. Okay. So next, I have to mention something regarding the ANOVA table, you know, what will be the value of TSS. TSS already I mentioned, y prime y. Today you learned about RSS. Okay. Now I'd like to say something about ESS, you know, so TSS, ESS, RSS, regarding these things, you should have some concept. And how we are getting an unbiased estimator for sigma u square. What will be the value of unbiased estimator of sigma u square or SU square? Okay. So in case of two variable analysis, we got this to be RSS by n minus 2. Here we will get the value to be RSS by n minus k. Okay. So RSS, you know, it will be E transpose E. So it will be E transpose E divided by n minus k. So these issues I like to mention, and along with that already you did. However, we will revise three different concepts of R square. What is the meaning of multiple R square? What is the meaning of simple R square? What is the meaning of partial R square? So, as a note, I added the differences between 3R squared in context of two variable analysis. However, in case of two variable analysis, all R squares are same. Maybe some of you, have some confusion regarding different types of R square. In context of k-variable analysis, there is immense importance of these three different types of R square. So once again, I'll discuss the points in detail. What is meant by multiple R square, what is meant by simple R square, what is meant by partial R square. So those three concepts, okay? And then we will discuss about several small numerical exercises, mostly confined in 2x2 matrix. That is, I'll increase one more explanatory variable. We are familiar with a single variable, and here I'll incorporate one more explanatory variable so that, we can solve the problems using 2x2 matrix formulation. Okay. So these few things I'll do, and I'll do it tomorrow. Tomorrow afternoon you have classes. So please check the formula, please check the assumptions, please check the model building. So several small things I first will like to add, and then I'll discuss one numerical exercise which will help us to understand how, using the matrix algebra, we can find out the value of beta hat. Okay. And for that, please revise, the part that how you take inverse. Here, if I tell you to find out the inverse, you have to use adjoint by determinant. Okay. Hopefully everybody can remember how we derive the inverse of a matrix. However, if you have some problem, confusion, so please revise that part, how to take inverse of any matrix. Otherwise, there is nothing, the things are very, very easy, no problem.